Alright, let's move on to paper 2 questions now, the longer ones, and we'll start with this Venn diagram question. We've been given a picture of the Venn diagram involving mathematics, which is circle A, further mathematics, which is circle B, and physics, which is circle C. To copy and complete the Venn diagram. Alright, let's just pretend that I've copied it here. We've got 50 students who study mathematics. Now that means there's a total of 50 students inside the mathematics circle A. That's a total of 50. I'm not really sure what numbers are going to go in these 3 spaces so that all 4 of these regions add up to the 50 students who study math. So let's just move on to other parts and see if we can come back to that. Okay. 38 study physics. Physics is C, so circle C should contain a total of 38 students. We have 26 of them right here. So that must leave only 12 other students that belong in this region. And for that matter, that just kind of correlates with this piece of information here, that there are 12 who study further mathematics, circle B, and physics at the same time. There's 12 in this region that belong to both further mathematics and physics. Okay, it says that 20 study mathematics and physics, so they're in the mathematics circle and the physics circle, but they are not inside the further mathematics circle. Oh, here's the 20. Yes, we've already got that done. Okay, so we've handled that, 10 study further mathematics, which means they are inside the B circle, but not physics, meaning they are outside the C circle. Oh, well, this must be this then. There are 10 who are inside the B circle, but outside the C circle. 12 study, oh yeah, we did this one already, that one's given. 6 study physics, but not mathematics. Yes, that's this one, right? The 6 that are inside the physics circle, but they are not inside the circle A of mathematics. And 3 study none, so that's these 3 out here. Great. And now we can come back to the very beginning, because we filled in enough information. 10, 12, and 20, and something should add up to 50. So let's do 50 minus these 3 things. Our 10 and our 12 and our 20 together give us a total of 42. So 50 minus 42 leaves us with 8 on the outside. And we've done part A. Write down the number of students who study mathematics but not further mathematics. So we're trying to deal with the number of students who are inside circle A for mathematics but are not inside circle B of further mathematics. So that's going to be this 8 and this 20. Those are the only 2 values which are inside circle A but are not inside circle B. That's a total of 28 students. Write down the total number of students in the school, so we've got to add together all of these numbers, and that will give us the total number. 8 plus 10 plus, 20 plus 12 plus 6 plus 3, and that gives us 59 students in the school. And then this little n in front means write down the number of people who are inside set B union C naught. Boys, is that... sorry, I really can't read my resolution. My resolution appears to say B union C, so perhaps I'd better give you 2 answers, just because I can't really tell what that says. B union C would be everything that is inside B or C. So here's B, and here's C. So what numbers have I just covered? That's going to be then 10 plus 12 plus 20 plus 6, and that gives me a total of 48. And I now remember, yes, that is the right question. It was B union C, a total of 48 people. Another way I suppose you could have done this is realizing that there's a total of 59, and we want everybody except for these 8 plus 3, these 11. 59 minus 11 is another way of getting 48. Alright, we've been given some 2 variable data. I can tell it's 2 variable data because the question tips me off that I'm dealing with x, y values. These are coordinates that can be plotted as a scatter plot. So I'm going to put these straight into stat, edit, and let's put in the x values. 45, 75, 66, 27, 44, 28, 60, 35, 73, and 47. Now let's do list 2. 30, 50, 40, 25, 30, 5, 35, 20, 45, 25. Alright, now I've entered the data. I'm going to go to stat and I want to calculate. Oh, I guess I don't know yet, do I? Let's look at the question. It says I need to calculate the mean number of trees. So let's calculate, because I've got two different variables in there, let's go to 2var stats. And obviously I'll be doing list 1 and list 2. Those are my only two lists. I need to find the mean number of trees. So the trees was my x variable. My mean I can see right here is 50. And the standard deviation of trees I can see right here. Don't take the SX, take the strange squiggly 0x. And if I round it to 3 significant figures, we get 16.8. The mean depth of the snow, so let's scroll down until we can see the y values. The mean of the y values is 30.5. And the standard deviation, if I scroll down to the standard deviation of y, the 0y or the OY is 12.33. 12.3 if I round to 3 sig fig. This is information you don't need anymore. Write down the product moment. It's fancy words. Write down the correlation coefficient. Okay, we know how to do that. We'll press stat. Hey, wait. I have to do something first, don't I? I need to go to my mode and upwards into my stat diagnostic to turn my stat diagnostic on so I can see what my correlation coefficient is going to be. And now I can press stat, calculate the linreg, and linreg will not only give me the equation of the line of regression, but it will also, because I turned my diagnostic on, will give me my value of r, which I can see down here below. If I round to 3 significant figures, I get 0.910. Write down the equation of the regression line. So obviously the equation of the regression line is in slope-intercept form y equals ax plus b, and the calculator in linreg showed me that my a value was equal to negative 0.669 if I round to 3 significant figures, plus the b value, which is negative 2.95. So in fact I'm going to change this to a minus 2.95. Part D, if the number of trees in an area is 55, estimate the depth of the snow. So the number of trees is my x value, so let's substitute that now into my equation and see what my estimated depth of the snow is. Negative 0.669 times 55 minus 2.95. And I get ooh, boy, not sure how to handle this answer. Let me think. Alright, well let me at least write down what I get and then think about what this means. How can I have a negative depth? I'm just going to have a look at my initial data for a moment. Yeah, something seems really quite wrong here. I actually don't even understand why I've got the negative value of A. So when my number of trees is high, I have a large depth of snow. When my number of trees is low, have a small depth of snow, so that should be positively correlated. Did I, sorry, let me check my stat one more time. A bad feeling I miscopied something. Oh, shoot, my A value is positive 0.669. Well, these things must drive you crazy when you're watching the videos. So sorry. Alright, let's do this again then. We're dealing with a positive 0.669. Times 55 minus 2.95. Alright, 33.8. Well, at the very least, I hope that you guys see that everyone makes mistakes, and you just have to seek what the mistake was and not get too upset about it. Just locate it and solve it. Decide whether the answer is a valid estimate. Well, the number of trees is 55. Does that fit inside our data? An x value of 55? Sure, our maximum value is 75 and our minimum value is 27, so 55 is safely within. And furthermore, is our R value, is the correlation strong enough such that an equation of a line of best fit is an appropriate method? And yeah, that's fair, that's pretty strong correlation, 0.9, that's pretty high, so I'd say yes, it is a valid estimate. And the reason, we could say that R is close to 1, so correlation is strong. And 55 is in the range of x values. Another way you could say this is that we're interpolating, and interpolating we know is a good thing. So when we interpolate, yes, it tends to be a reliable estimate. If you extrapolate it by taking a value of x that was outside of your x values, then no, it's no longer reliable. Alright, so let's move on to part B, where we've got, looks like it's going to be a chi-squared test. We need to write down the total number of male students. So we've got 14 plus 6 plus 8 gives me 28. I suppose while I'm at it I can work out the other sums. 31 plus 24 plus 17 is 72. And there's my super sum of 100. 8 plus 17 is 25, 6 plus 24, and 14 plus 31. And there we go. These also add up to 100. So the total number of male students is 28. We need to show that the expected frequency for males whose favorite color car is blue, is 12.6. So we're dealing with this cell here, the males, the blue car. In order to show that an expected frequency, we need to use the sum of the row and multiply by the sum of the column, and then we divide by the supersum, which is all of the 100 people. And so 28 times 45 divided by 100 gives us the 12.6 that we require. The calculated value of chi-squared is 1.367. Write down the null hypothesis. Alright, null hypothesis is always independent, right? So we would say the null hypothesis. What are our factors? Let's see, this one, males or females. This one's clearly gender. Blue, red, green, those are colors. What are we dealing with? Colors of... Okay, so preferred car colors. Okay, so these two factors, if we're dealing with a null hypothesis, we're saying that these two factors have got nothing to do with each other. They are independent. So, your null hypothesis, H0, says that gender and choice of car color are independent factors or variables or classifications. Right, write down the number of degrees of freedom. So, we know that the degrees of freedom is found by taking the number of rows and then subtracting 1, and then the number of columns and then subtracting 1, and we multiply these two amounts together. That gives me 1 times 2, and the degrees of freedom is 2. Write down the critical value of chi-squared at the I have a funny feeling I changed this question for you already, and I gave you that the critical value was 5.991, and we needed to conclude whether the null hypothesis should be accepted. And because your chi-squared value is 1.367, and 1.367 is less than the critical value, that is to say that chi-squared, our calculated value, is less than our critical value k, that means that we will accept the null hypothesis. And accepting the null hypothesis means, of course, that yes, gender and choice of car color are indeed independent factors. And the last question, you need to sketch this graph between -2 and +3. So we've already seen from earlier on that y equals 2 to the x is an exponential growth function. And so let's see, -1, -2, 1, 2, and 3. So there's our domain from -2 to 3. This is an exponential growth function. And it goes through 1 because I've got nothing in front, right? This is like 1 times 2 to the x. And so that's my y-intercept. We need to indicate where it intersects the y-axis. Yes, I've done that. It intersects at 1. Okay, so I think I'm done on part A. Write down the equation of the asymptote. So the asymptote of any exponential function which hasn't been shifted upwards or downwards is along the x-axis, y equals 0. Part C, on the same axis we need to sketch the graph of y equals 3 plus 2x minus x squared. Wow. I don't think we've done a question like this before, but it's a good one because it involves quadratic equations too. So we need to graph this function. Let's use the calculator to do this. So let's clear my old functions. Oops. Clear. And I'll put in this function 3 plus 2x minus x squared. And I'm going to make sure that I graph this on a fairly normal. So you remember I've changed my window earlier on, so I'm going to press zoom, that's the middle button there, zoom 6 to put my thing back to normal, and I get a picture of my parabola. So let's make a sketch of this. I can make a sketch by figuring out what my x-intercepts and my y-intercepts are. So my x-intercepts, these things are otherwise known as zeros. So let's find these zeros. Second trace 0. And I need to move the cursor to the left of my 0. So I'm going to be looking for this 0 first. I've moved the cursor to the left of it. Let's move the cursor to the right of it. There we go. And let's move now for the guess. Let's move the cursor right on top of it as close as we can. It tells us that the 0 occurs at -1. So one of the x-intercepts of this quadratic y that we're about to graph is at -1. Let's find the other one. Second trace, let's go down to zeros. And our left bound, let's move the cursor a little bit to the left of that other 0. Good. A little bit to the right of this other 0. And then for our guess, let's park it right on top, or as close as we can. And we find out that the other 0 occurs when x is equal to 3. That's good information. We now know that we've got an upside down parabola that's going to go through these two x-intercepts, but we can find some more information. Let's find out where it intersects the y-axis. At the y-axis, we know that x is equal to 0. So let's find out what the corresponding value is when x equals 0. We'll say second trace, and we want to find out what is the value, so option 1, what is the value of the function when x is equal to 0? And this will tell us the y-intercept. It occurs when y is equal to 3. And there's one more piece of information we can find is the vertex, which is known as the maximum. And so we'll say second trace to go into calculate maximum. And we need to put the cursor on the left side of the maximum and on the right side of the maximum. and then we'll stick it right on the maximum, or as close as I can get for my guess. Tells that the maximum occurs at, alright, now let's interpret this sensibly. The x value is 0.999999. Obviously that is just simply equal to 1 with a y value of 4. And so there's our vertex and all of the other points. There we go. There's a picture of the quadratic, and we've intersected where it intersects the x-axis and the y-axis. Part D. Now let's find out where these two equations are equal to one another. We need to solve this equation where the quadratic is equal to the exponential. So we'll go into y equals. I've already got the quadratic as my y1. Let's put in as y2 the 2 to the power of x. And let's see that on the graph. There it is. And you can see the same two intersection points here and here that we've got on our graph. Let's find out what those two values are. So we'll say second trace intersect, so that we can find the intersection between that. Yes, that's the first curve. Yes, that's the second curve. I'm going to put my cursor on the first intersection point I'm interested in finding, and I find that x is equal to, if I round to 3 significant figures, I get negative 0.857. Probably never hurts to write down additional values. There we go, guaranteed full marks, and now then I'm just going to satisfy myself. Negative 0.857, and the other solution, second trace intersect, and that's my first curve. Yes, that's my second curve, and my guess, it looks to be like they intersect around an x value of 2. So I'll type in 2 for my guess. In fact, they intercept at 1.76911, so let's just call it 1.77 if I round to 3 significant figures. Part E, write down the maximum value of the function. Well, I already found it in my vertex, that the maximum value, the highest value, and value, by the way, always means the y value. So the word value means the y coordinate. The maximum value at the vertex is 4, and so that's my maximum value. And that's the end of the November 2009 paper. Good luck studying for your exam. Bye-bye.